Hello and welcome to part 2 of the series where I show you how to communicate with the Raspberry Pi and a Pico W using BLE. Last time I showed you how to send data to the Pi from the Pico. Now we'll show you how to use bidirectional communication. This simply means communicating from the Pico to the Pi and vice versa. I will show you the code and then we will run a demo of the code. Let's get started. Alright, so let's get things started. So I have the code here, both code we will be using for our tests. Now, here we have Pico send receive.py and Pi time send.py. That should say Pico, but it doesn't matter. And of course, I have my Pi 4 here. I actually have roughly the same names for the code here. I have Pi send receive.py and Pi time send.py. So we'll start with this one first, which is Pi send receive. So as you'll see here, we replace, so everything is still the same. We simply replace the MAC address with the MAC address of the Pico. Make sure to change this when you're using it. Everything else is still the same LED. I also added the same variables. Everything else is still the same, except I added this function called send data task. So, send data task simply says that we send a message. Now in this case, I'm sending a message called hello from central, and encodes it, and using UTF-8 in the while true loop, we send the message, and then of course we wait 2 seconds. You can always change this. Now, while we have this code, we must make sure to add it to this, which is our create task. So we'll create the send data task client. So we're going to need that. And this is important because whenever you have a new task, you need to add it here. But after that, yeah, everything else is good to go. So I'm going to exit out of here. So first thing we need to do, so to set things up, we actually need to go to our documents, and then we'll go to Bluetooth samples. We'll activate our library here. So there you go. Now before I do, I actually do want to show you the other code. I planned to save this until after, but I'll show you the other code anyways. So I'll show you the time send as well. So this is pretty much similar code. The only difference is we imported time, we set up local time, and then we use string format time, where we set it up as year, month, day. You can always switch these, but I choose this because it's what I'm used to. And then we have hour, minute, second, and then now, which is the local time. So other than that, the only thing that changes is that if we go to send data task, we do today.encode, and that's it. Everything else still stays the same, and that's it. So nothing else changes here. Now let's go back to the Pico because I want to show you the other one. So I showed you send receive. So here it is. Now this is the same code we had last time. The only difference is I added the count here. We just have the send data task, and then we have to make sure to add it to our tasks. So we have, let me make this bigger, create task, send data task, make sure to have connection and read characteristic. So make sure you set that up. But other than that, it's pretty much still the same code. However, on time send, I actually had to make some changes. Yes, I import time and I have local time here, but I actually had to format it like this. And this simply formats it to the date that you'll see soon enough. And the reason I had to is because there is no string format for MicroPython, so you actually have to format it like this. But other than that, all you need to do is replace message with today and message count. That's it. So other than that, that's really it. There's nothing else. It'll send the data task, and that's it. So what will happen is it will send the time of that the Pico records to the Pi, and the Pi will send the time of the Pi to the Pico. So hence bidirectional communication. So let's get started. All right, let's get started. So I have this set up ready to go. Now, remember, we need to start running this first. So we'll run send receive first. It's advertising. So we'll make sure to run Python 3 pi send receive.py, and it's waiting to hear back, and it's connected. And you can see it says hello from peripheral and hello from central. Now, I didn't show you the wiring diagram because it's pretty much the same as in the first part, so there's nothing to change from there. But as you can see, it is sending hello from central, well, it's receiving it from the Pi, and it is receiving hello from peripheral from the peripheral. So this is basic bidirectional communication. So I'm going to exit out of this now on the Pi. So I'm going to stop here. And okay, that's all well and good, but what if we wanted to record time? Well, or at least send the timestamp. We can do that. So we'll do exactly that. So we will send this code to run, and then we'll run this. Will connect. It's connected, and as you can see, other than adding the numbers, it's working. So here we have the dates. You can change this to whatever you want, and here we have the message received, and as you can see, it is sending it. So it is actually working very well. So this is if you wanted to, for example, send the timestamp of a certain application and you needed to know what time it was. So this is a good way of doing it. So there's many things we can do with bidirectional data, but I just wanted to show you the basics first. So let me exit out of this. I have the LED on, so I had to make sure not to leave it on by accident. So I'm going to stop here, and there you go. So bidirectional communication now works on the Pi and the Pico. Thank you for watching, but we are not done, as next time I will show you how to read the values of the temperature sensor on the Pico, and then I will show you how to read the values of the temperature of the CPU on the Pi. So stay tuned for that, and I'll see you next time.